Good afternoon, at least a nice sunny afternoon from my side here in Austria. My name is Keith Peterson. I'm the eCognition product manager, and I want to welcome you to our next webinar here. We're a little late on this one, but better late than never, so to say. And I'd like to welcome you to eCognition 10.1. This is our latest Trimble eCognition software release. It came out in May, but we took our time to put a good show for you together here on what's all the new stuff, the new cool happenings in version 10, and that's what we're going to run through today. Now, before we get started, again, that's who I am, project manager, so you have a face to go with the voice here. But before we really dive into things much further, the rules of the webinar, everybody's on listen only mode here. So you're muted, it's intentional. But if you have questions, please do not hesitate to ask us these questions throughout the webinar. I have with me the beautiful voice behind our eCognition deconstructed videos. Matthias Stengel is my wingman today, and we will be fielding questions during the webinar. We also have a block of time set up at the end. So get those questions in. Better to get them in during the webinar so we don't have to wait at the end. But you can ask us anything, anytime, as long as it's revolving around eCognition. The other thing you may want to ask, or you're probably asking yourself, will the session be recorded? Yes, it's being recorded, and we will of course make it available on eCognition TV in the days to come. So that being said, I hope everybody sees my screen. I have been known to jump the gun and not share the screen. So Matthias, give me just a brief thumbs up that we're broadcasting, the PowerPoint's visible.
It looks very good, Keith. You're ready to go.
Thank you. Awesome. All right, so we will continue. For those of you that might be new to Trimble eCognition, just a brief description of the general idea. We are a software platform that gives you tools for automating various elements of feature extraction. So we can take our elevation, raster data sets, vector data sets, and we want to identify certain features in those. Maybe that feature is a forest, maybe that feature is a road, or a single feature like a tree in the landscape. This has traditionally been done manually, but eCognition provides the tools to automate these processes. So you can take large chunks of data and automatically process them through the software based on your rule set and identify these different features or produce certain classifications like a land cover classification map. For that, we have different tools and concepts. One of these that I guess we're famous for, you could say, is this concept of data fusion. I sort of alluded to it a few minutes ago. We can combine different data types within eCognition, and we can draw on the attributes, the features, the characteristics of those different data types. So we can, of course, read in all sorts of different raster data types from all types of different sensors, satellite, aerial, UAS, submersible, all those types of imagery coming in. We can combine that with vector files. So you could have a shape file geodatabase, you can bring that in. It has attributes associated with it, and we can read those and then see how they interact with the imagery. On top of that, we also support point clouds. So LiDAR, photogrammetric point clouds, you can bring those in to the analysis into your project. And we can also pick out elements of those data sets, combine them with descriptors that are in your imagery, or I should say, the vector data sets. So what we're really doing is allowing you to use the full potential of that geospatial information that you have to describe a certain feature, a certain object that you're trying to find. Another great function within eCognition is what we call method fusion. And by this, I mean the ability to tap into different types of remote sensing or feature extraction methods. So we have the traditional knowledge base, where I as a user am transcribing my knowledge, expert knowledge of what a feature looks like, and telling the computer, this is what you look like, you use this feature, this description. We also have unsupervised classification, supervised classification, And we have computer vision through template matching. And last but certainly not least, we also include access to deep learning through convolutional neural networks. But not only can you use these different methods alone, you can also combine them seamlessly within a single rule set and go from a knowledge-based classification, flow into a deep learning, tap into certain layers, so this heat map layers coming out of a deep learning classification, and then go back into a knowledge-based classification, or combine supervised with knowledge-based. All types of combinations are possible. All right, so we're on version 10.1. Some of you that could be absolutely new, but for others, let's get you just a reminder of what we've been doing in the past. Maybe you forgot some of the cool stuff we did in 10. So within version 10 that came out last year, we really did an overhaul of our, say, our UX and UI, giving it a new styling, simplification, making tools easier to find, giving our icons a complete overhaul, just making them more 4K compatible, no longer some, what I like to call the sort of the fuzzy Tetris or old Nintendo icons from the 90s. We also took a look at pre-processing functionality, really boosted that, increased performance, and then again, looking at usability on a number of spaces. That was version 10. We followed that up with a few short, what we call maintenance releases. So we added some support for TensorFlow within the GPU world, really getting that up to date for CUDA 10, and also had to go in and fix a few bugs that popped up within our supervised sample statistics. All right. Within 10.02, we made some updates to this boost library that was really mainly for a security vulnerability. We're always keeping things up and tidy for you there. Also went in and looked at some of these supervised sample statistics we had to fix again to support some imported files there. And continue always looking at how we improve our dialogues, things of that nature. So that brings us to 10.1. Like I said, it released in May. It actually released on May 19th, and that's what we're going to get into today. As you can see, the journey does continue, but we don't have any dates, version numbers locked in right now, so that you'll have to tune in with us in the future. Again, just in terms of if we have people from sales online here in terms of ordering and availability, or anybody wondering why they maybe didn't get access to 10.1. The release date was the 19th of May. And all customers that had a valid maintenance contract with us received notification and are, of course, eligible to download that software. And you can go right to our eCognition download page, download current version, and grab this version. If you remember any URL today, ecognition.com, and that'll get you all the information that you'll need. So now, getting into version 10.1, what are some of the highlights? What have we been working on that went into this version? I was actually really pleasantly surprised when we wrapped it all up at the end of the day. We had several focus areas here. So one is extending our deep learning support, and I'm going to get into details in these in just a moment. We wanted to offer more surface calculation tools, new tools for classifications, and some new features that will help with classifications. Some improvements to some of the processing behind the scenes, so always kind of tweaking those in there as well. And then mainly here, this cloud readiness, expanding out. We've been doing a lot in the world of cloud capabilities, which I'll also highlight. So the big one that's really been on the tip of everybody's tongue, at least in our offices lately, is this expanded deep learning support. We have now taken our use of deep learning, and we're adding the capabilities now so you can take an external pre-trained TensorFlow model and bring it into eCognition, okay? I've highlighted these important words in yellow because they are essential. So you can use external models. They must be pre-trained, and they must be TensorFlow or DF models, all right? So this really gives deep learning users an opportunity to save time. So you can, if a model is pre-trained, you don't have to get down into the nitty-gritty of doing sample generation, sample collection, that is very time consuming in the world of deep learning. So you can take these pre-trained models and just load them in. And we're also allowing access or expanding access for people that may not be a deep learning expert, and allowing them to get on board. We're bridging that gap between these two different domains. Right? But again, a very important thing to note here, currently we only support these semantic segmentation model types. All right, and I have a little diagram that goes along with that. Sorry, wrong direction. So when we look at all the different models, when we're out there, on various social media networks, we always see these object localization type models. So that's that B category there with the pretty little boxes. These are not the models we are currently supporting. We continue to support semantic segmentation. So that's the one with the little box drawn around it, C. So if these are the types of models that you're bringing in, these external models, then you are good to go within eCognition. So that's point number one. Point number two, we use this, you can import the save model. So this is a folder format, all right? So pretty similar to a file geodatabase. And to load this save model, all the user really needs to do is to find that folder when they navigate to it from the algorithm, and this can be loaded via the load convolutional neural network algorithm. All right, so you'll have several options there. You can either load an internal, let's say, eCognition model, or you can load this save model. Final note is that to use one of these save models, or to use a model saved in a TF hub format, these need to be converted at times. So the conversion to a TensorFlow save model format is necessary. And the good news is you'll find that in our documentation, we even have an example of the Python script that you can use to make that conversion, and then you can upload to developer, and away you go. All right. So this is one of the big areas we've been concentrating on, and we continue to work on moving forward. I mentioned the surface calculation tools. This is great because it always gives us an opportunity to show some of the real great optical effects that we have in the software. It's now possible to generate hillshade layers based on a DSM or a DTM within eCognition. So DSM, DTM in a raster format. We can generate and derive the hillshade from that. So we've seen here, this is one that Matthias put together from the surface of Mars, and then use some nice colorations to visualize there. It just gives us a great understanding, or an increased understanding of what's going on within elevation data sets when we're working within eCognition. And if you tune into the deconstructed video on eCognition TV, you'll also find some great use cases for a hillshade model out there. On top of that, we've added a ridge filter algorithm. This will allow you to, again, you can input any raster layer into the ridge filter algorithm, and it's really designed to find, as the name implies, ridges. So you can find ridges along either mountain ridges, but one interesting area we've been experimenting with this on as well is for crack detection. So it's another way, edge detection as well. You can compare the results to some of the other traditional edge detection filters we have there, Sobel, Canny, things of that nature. All right, this one was long on our list. It was nice to see it on the wish list within the eCognition community as well, and we said let's go after this. We wanted to look at this topic of majority vote, and we actually ended up going with two different options. The first is we introduced a majority filter algorithm, and this will work, of course, on a raster input, and it really can be applied to remove some of the, say, the salt and pepper effects that you get in certain imagery, or say thematic layer simplification that could come into effect when you're bringing in, say, a thematic raster. We also have a majority vote feature. Okay, and this feature, it will use, say, some of that traditional majority vote. It really builds on the contextual relationships between image objects and makes classification easier in this context, and no longer has to be done outside of eCognition. So let's just take a look. If we looked at the result of applying a majority filter here in this 3x3, this would be our output. And for the majority vote feature, more complicated, we had an initial input layer. We have a different type of, say, reporting object structure here. That's the great hexagon segmentation from Zetkis, University of Salzburg. And we can take those, the majority vote. You can see there's two different types of majorities. This is what we're going to take a look at in our live demo. So we'll get there later, but you can apply majority vote based on the pure count or on the majority area of the sub-objects to that super object level of those reporting objects as I've described it here. Finally, in terms of cloud readiness, we've already had the Docker containers available for eCognition server to move from, say, those on-premise type machines to cloud computing, really ease that transition. And with this release, we've taken it a step further. We've actually taken our license server and we've put that in a Docker container for you. And what this really means is that it makes one-line deployment possible, really making things more user-friendly when putting your big operations into cloud environments. All right, Matthias, before we jump into the software demo, are there any questions out there?
Actually, not yet, Keith. So you can actually continue with the demo.
All right, great. So back out of the PowerPoint here. And bear with me a second as I gather the mouse. So now you should all see the eCognition screen here. We're in developer. I have a project already loaded. Some 4-band imagery, red, green, blue, near infrared. I have a thematic layer here. This is an existing classification, and I'm gonna use it to apply the majority vote to. Great imagery. This is from Lake Champlain, an area in Chittenden County in Vermont, where I grew up. And to steal a great line from Garrison Keillor, it's not a great lake, but it's a pretty good one. And this is an area where we're going to look at today, taking, like I said, that classification. If anybody's interested, the classification actually did come out of eCognition through deep learning, but I want to now take that and apply some of these new majority features to that. So the first thing I'm doing here, I'm going to be working in 2 maps. So I'm going to essentially just copy this initial data over into map 2. I'm still staying in my main map here, and I'm now going to apply this hexagon segmentation. Like I said, this is a great customized algorithm that came from Dirk Tita and his colleagues at Zetkis at the University of Salzburg, and you can download this customized algorithm from the eCognition community. Just go there and search hexagon, and you will find a hit for that. So at first we don't see anything. Let's just turn on our image object outlines over here. That is the result of the hexagon segmentation, and this is what we are going to use essentially what I was referring to later. These will be our reporting objects on the final classification. Now I'm coming into this tab on map 2, and this is where I'm going to be doing the rest of this analysis. So I'll switch my view onto map 2. It's the full subset here. And the first thing I'm going to apply is a vector-based segmentation. That is because I have my classification I stole from my other project here as a vector layer, and I'm gonna just imprint those image objects outlines here. I also have the classification values stored as a class, and I can use the assign class by thematic layer to simply apply that and here we go, voila, I am back to a classified land cover state here. Next thing I want to do is I need to get this hexagon image object level into this map. So I'm going to first of all create a new image object level, call it hexagon here, and I'm simply just copied the image object level that I have the classes for at the moment, and I've copied it above. And now I want to just unclassify everything that's in here. So if we go back, we can turn off the classification. We're looking at 2 levels here. So here's now I'm just looking at the level called hexagon in this view. The next thing, I still have all these different image objects here. Good indication of that is down in the lower right here. I've got around 13,000 image objects. So I'm just gonna merge those and essentially get back to nearly an original state. All right. So now what I've done is I've created an empty image object level above the classification level. So these will be my super objects for this analysis. And what I want to do here is I want to take those hexagon image objects created in the main map, and I'm going to use as a synchronized map algorithm. I'm going to bring those over, and I'm going to put those image objects here in this map. All right. So the synchronization can take a few moments, depending on obviously the size of the maps to be synchronized and image object complexity. Right. So now if I turn on the outlines here, I should still see my my hexagon image objects here, but I can also, just to make sure, I also have those other classification image object outlines with the classification below. All right. Finally, what I want to do here is I actually want to classify this layer of this image object level hexagon, and I want to classify it into my various classes here that are from that land cover classification map called bare soil, forest, grassland, urban, and water. I'm using a classification algorithm to do this because what I want to do is apply the class description coming from the majority vote features. So let's just open up one of these classes and we'll take a look. Open up forest. Within this, I have my class description here. You can see that it's, I'm referencing, you can edit this as well. We'll take a look. And I'm using a majority vote based on area. And I'll show you where these are located in the feature view in just a second. So I mentioned before, I have 2 different types of majority vote. I can use a majority vote based on area, or I can use a majority vote based on count. For this, I'm going to look at, I'm going to classify based on the area. What this will then look at is the complete area of all my sub-objects if the majority area of those sub-objects equals forest. Then my super object, that hexagon object, will then assume the classification forest. And I've done that, I've repeated that class description for all the other classes as well here. So it's a nice way just of being able to apply that classification in a single step. As you can see, it goes very quickly. Turn off my image object outlines here. And I will come in and click on one of these objects here. Maybe this one is a good one, yes. And what this gives me a chance to demonstrate too is that there can be differences in your majority vote classification based on the type of majority vote that you are using. So you can see here, if because I've chosen this majority vote based on area, this hexagon has been classified as grassland. But if I were to look at these sub-objects and consider the count, there are more image objects in this hexagon that are assigned the class forest than there are others. But the majority area is of course grassland. So this is where you can take a look and get into these different uses of the majority vote features that we've included here. And like I said, the nice thing is they are features, so all you can come in here and do is majority vote, and if you just start typing it, you'll be able to search, and you'll find that it's of course listed in my recent features. I've just been using it, but this is it's an object feature. It's in the relations to objects, and it's a relation to the sub objects, right? Because I'm looking down at the initial objects in the sub image object level, and it will be something you can create here. All right, so I've created a one for the area and one for the count as well. And you can use this now like any other feature within eCognition, and use it in other types of classification algorithms as well. All right. Matthias, have any questions come up on some of this live demo material?
Yeah, there's a question actually. If you could use this majority vote also in the assign class algorithm?
Sure. Yes, absolutely. You can take it and use it in assign class. For that, I would have just sort of built 5 different assign class algorithms and launch them one at a time. But sure, you can also use it there as well, of course.
All right. Yep, that's it.
All right, excellent. But if anybody's interested, we will probably get this rule set. Like I said, it's very it's meant just to get the concept of majority vote across, and but we can make it available in the community if there is interest. So let us know if you like that, and we'll upload it, and you can take a look on your own time.
Okay. Hey Keith. That's just one more question coming in. Sure. Will this feature be usable with the multi-resolution segmentation? Yeah, maybe I can answer it. It's a simple yes, right? So it doesn't matter how the objects look like. You can compute this majority vote, and the objects can be also created using the multi-resolution segmentation.
Yeah, that's a great point. Matthias, you hit it on the head. You can use this with any segmentation, the objects coming out of any segmentation. So it could be from the multi-resolution. You could use it if you wanted to say a chessboard reporting object. Go with a chessboard, or you can bring in some sort of custom objects that are in another vector layer, and again use that vector-based segmentation. Because all of those segmentation pieces will support this. The one thing you want to make sure is just pay attention to the relationship between sub and super objects. It's not possible to have a smaller reporting unit than your sub objects. Okay, but it will Keith, support all the others.
Yeah, actually now there are more questions coming in, which is nice. There's a question: what is the purpose of the hexagons?
I personally have never used the hexagons. I know, Matthias, you used them back at your time at the University of Salzburg, but in terms of when doing a simplification, it's applying a minimum mapping unit, something of that nature, there are certain believers that the hexagon is a better representation in terms of its shape for doing such reporting. Or Matthias, maybe you have more information than on the way you've used it in the past.
No, I mean, that's exactly how I understood it as well. But the second of all, also it looks good, right? It looks different if you create a heat map with hexagons. That could also be a point. But yeah, it's just a hexagon has more connection to the neighbors than having, for example, chessboard segmentation. Yeah, I think that's the main point of using hexagons. Hold on, there are more questions coming in. How does the majority vote area break a tie between classes?
Oh, that's a good question. Oh, I'd have to go back into the documentation to read that. It could be that something is undefined. That's a good one. I'll have to follow up with engineering on that, but I will track the answer down for you. Of course, with the majority filter, because you're using an odd number of pixels, that it is not possible. There will be a majority, but for say the area, I'd have to go back and reference our documentation on how that gets determined.
Mm-hmm. Okay, and I just see that actually Dirk Tide, who created that hexagon segmentation rule set, replied here, and I'm going to just put that into the chat so everyone has a chance to read it regarding the hexagons. Right? Yep,
he would be the absolute perfect person to ask, since he's created this this wonderful customized algorithm that's available in the community. Great. All right. Yeah, if more questions do come in, don't worry, we will get back to those. We'll continue with the presentation here. And that was our live demo looking at the customized, or excuse me, at the majority vote features. And just to kind of wrap up here, version 10 summary. Again, we're delivering a new range of functionality here. We're also aiming to improve some of these complex workflows, so particularly some of the deep learning workflows out there, by allowing you just to simply bring in an external model. You can save a bunch of time and then a number of algorithms and work ahead of time by falling back onto those. And again, building out this great function within eCognition, always being able to use context in describing image objects, taking that a step further now by using this sub-super object contextual feature with majority vote. It's just been good. And finally, simplification. Simplifying setups in the cloud. I think that's something more and more of our users are moving towards, particularly if they're in big production environments. And yeah, that's what we really put into this release. It's been great to build this, and I've been excited seeing the different use cases. We've already been seeing folks apply the hillshades in different parts of the world, and we'll be excited to see where that continues. Always follow up with this on each webinar because we're always building out our eCognition resources. This is something that also happens during our development phases. We're not just developing the software, we're also building out all the valuable information that goes along with the software. So I referenced it a number of times in this presentation, our eCognition community. Please go there if you haven't already. You'll find discussions, the wish list. So if you want to get that one feature you've always been looking for into the software, put it in the wish list. There's voting, and we in part use some of that to determine what's coming into the next version. So let us know. But more importantly, you'll find tutorials, these demonstration rule sets. You'll find links to webinars and all the different material that we have here. And you'll find that hexagon segmentation algorithm there as well. So you can go into the library section and you'll get access to all this type of stuff. Within social media, we're also very active. We have our LinkedIn group. So if you want to kind of keep a bead on the happenings within the eCognition world, great place to get updates. I also mentioned it here, eCognition TV. This is where we put webinars, learning videos, so please go there. Matthias has been real busy getting a lot of great learning content into this. You can use, I think we have now a great introductory course for deep learning here. You'll find this webinar available there as well in case you forget something. You can always use that to jog your memory. Yeah, the folks in eCognition support, couldn't do it without them. If you have software questions, licensing issues, software setup, don't hesitate. Go into eCognition.com. You can submit a support case directly from there. And the great thing now is by using the support portal, when you're entering your case and the details, you'll get recommendations on where you could find other resources that may help you at that time. eCognition blog. So we have here a number of different, say, software news or customer stories. I'm always reviewing various applications of the software from across the world as they come to me. Go check that out. We have our documentation. Like I said, we was actually looking through the documentation earlier today just to double check things on the deep learning and what type of formats, TensorFlow formats are there. And I made the reference, go there, check it out. There's that example for the Python script that you'll need to convert files into a saved model, which you'll then need to use those external libraries. All right, webinars, case in point here. And training, yeah, it's difficult to do our great on-site trainings here in the days of COVID, but we are always building out our training resources, and Matthias has again been incredible here. Number of online courses or number of free courses online where you can get access to the data, the rule sets, everything that you see Matthias sometimes using in his deconstructed videos. You can go there and get more. All right. Great. We have a good amount of time for question and answers. It's not always the case. I'm happy we've been able to get a bigger block today. But yeah, if more questions have come in, this is the best time to get them answered. Don't be shy. There's no such thing as a bad question. So Matthias, anything else new here?
Yeah, so there's one more question, a more general question regarding what GPU users have to apply deep learning and things like that.
Okay, I think the first thing to say is that you do not need a GPU for the deep learning algorithms. You can also run it on your CPU, but of course, with GPU, you benefit immensely on the speed. And I believe for the latest specifications, it should be in our system requirements documents, but we currently have the NVIDIA GPU is required. But the exact, say, build and model numbers, I don't have sort of at the ready at the moment. But yeah, like I said, you'll be able to find that there, or there might even be an FAQ in it on the community.
Yeah, good. Next, some questions are coming in.
Great.
Does 10.1 use our existing 10.0 license?
Yeah, this is a great thing. You won't need to update, say, your license server to do a 10.1, so you can use your 10.0 or your 10.0x license server, and you can simply download a developer, run the developer installer, and that will give you version 10.1.
Okay, next question, a bit of a different topic. What options do you have for using the LiDAR point cloud directly?
Yeah, so within eCognition, first of all, if you're looking to bring in a point cloud, it needs to be in LAS or LAZ formats. Those are the two supported formats. The sensor type doesn't matter. It can be coming from aerial LiDAR, it can be coming from terrestrial LiDAR, it can be coming from a photogrammetric point cloud. Just make sure it's in one of the two supported formats. Within eCognition, you of course have the options to rasterize your LiDAR or your point cloud. When you bring it in, there's an automatic default rasterization. I believe it will automatically rasterize the intensity values, but you can also rasterize a number of different elements of the point cloud, and you can also work with the point cloud directly. So you have access to point cloud features, and there I believe it's that common list from ASPRS on point cloud features. So you can look at RGB values if those are stored in your point cloud. Of course, your your z values. You can look at if it's if your point cloud has an existing classification, for example. You can also consider that information coming directly from the points, so you will not need to do any rasterization to access that. There are obviously different reasons why you want to use one over the other. Of course, a big advantage of rasterization is looking at processing. Just processing raster images is faster than native point clouds. But you can access both and use both as features for classification within eCognition.
Perfect. Next question here. Yeah, I think it's mainly, is it possible to apply the CNN algorithms to pixel-based problems as well, and not only on objects?
Sure. Yeah. Actually, since we're using this semantic segmentation approach, the output from the CNN will be a heat map layer. So you're going to get, obviously with pixels, that's a raster layer. Each pixel will have a value between 0 and 1. 1 being 100% say confidence in that this pixel belongs to whatever the class was, and 0, of course, 0, very low. And you can then use that layer, that raster layer, in any way you want to within eCognition. You could take it and apply, if you're looking to do a pixel-based analysis there, you can certainly apply a chessboard segmentation with a value of 1, and then just classify each pixel based on a confidence value that corresponds to forest and one to grassland. If that's what you really want to do, then you do have that option available. So.
Okay. Next question. How does Trimble license cloud instances? We might want to license hundreds.
Hundreds of cloud instances. That's great.
Sounds
if you want to do that, then get in touch with us. Right now, there's some different options available out there. And my recommendation would be to reach out to us directly if you're going in the direction of such a say a large cloud payload, if you will, and we can discuss that in detail, certain pricing options that are available there. But where there's a will, there's a way, so to say. But yes, we can look at these big types of machines. It is possible, and you don't have to go through the traditional server price setup for that.
Yeah. And there's another question, if we have a test version or something, maybe I can answer that. If you go to eCognition.com, you're going to find, or if you look for the trial, eCognition trial version, you're going to find a trial version, which is for free. And you can download it and test the software and also use deep learning functionality that's implemented, right? So that is possible. Another deep learning question here. If a semantic segmentation model was trained on 512 times 512 pixel images, I guess, is it possible to apply the model in eCognition on a large image, and what will be the required steps to do so?
It should be possible to apply the model within eCognition 500 by 12 by 512. Sorry, my deep learning expertise isn't say deep enough, excuse the pun, to know what would be specific about a 512 by 512. But in theory, it should be possible. So this was a pre-trained model, if I remember correctly. Again, to apply a pre-trained model, you need to consider those three things I mentioned before. It's a semantic segmentation type, B, that you have it in you have a saved model, and that's the format that you have. And if you need to do any conversion, you need to use that Python script that I referenced. But yes, you can apply these to larger images, well, whether it's the whole Sentinel scene, Landsat tile, that is, of course, possible.
Yep. Now 2 easy questions, Keith.
Great.
I think so. Is it possible to use drone images to rasterize and to classify? I think also drone images referring to point clouds acquired from drones.
So you can use imagery, whether it's RGB, near infrared, doesn't matter how many spectral bands you have from the UAV. You can use that drone imagery within eCognition. If you are bringing in a point cloud that's derived from drone imagery, so something a photogrammetric point cloud, yes, again, you can. You can also use say LiDAR that's been collected with a UAV. You can bring that in. Again, it's just the LAS or LAZ formats would be required there.
Yep.
But resolution isn't the limiting factor.
Mm-hmm. Yeah, next question. Maybe I'm going to answer this one. Is it possible to apply unsupervised classification at object level? Oh, unsupervised, interesting. So we have a tool for unsupervised classification on pixel level. Let me think on object level. To
be honest, I'd have to also try it. But one thing you could obviously do is you get that unclassified result, and you can again use that, just take that raster layer that you have as the result, and you can transfer it to image objects based on a whole bunch of different features. You can use the assign class algorithm, classification algorithm, and get it to where you need to be.
Mm-hmm. Yep. And what else? Once the detection of different classes is done, for example, roads, does eCognition have a vector simplification tool to adjust the vectorized objects?
Oh yes, absolutely. That's what I always tell people when I meet them is, the classification is only part of the battle. Once we have image objects classified, that's where the real fun of eCognition truly begins. You have so many tools available to do what we call refinement. It could be image object refinement. So taking those results of the user want to do a pixel-based analysis on CNN, you can take those and then you can start refining those pixel-based results with the object-based tools. You can also take advantage of a number of native vector tools within eCognition. So you can take, say something, if you have those roadways, you'll notice when you initially convert the image object to a vector object, of course it could be a little jaggedy, sawtooth edge based on the pixel boundaries that we have to maintain. But you can use various simplification, smoothing tools within eCognition to get those cleaned up into, say, that GIS ready format that a GIS user would expect.
Yeah, and maybe to the previous question, the unsupervised classification at object level, I think that you could use a workaround, as I think that's also what you meant, Keith. So you could create a raster layer with the mean values of objects and then feed this into the unsupervised classifier, for example.
Right.
But unsupervised classification requires pixel layers as input, but you actually can convert the image objects to a pixel, to a raster layer, and then use that as input. So yeah, it should work, I think. Okay, the output of eCognition file, is it possible to use it in ArcGIS?
Oh, absolutely. I always tell people 99.9% of our users are GIS users. So at the end of the day, eCognition is not, say, this a mapping software per se, like GIS is. We don't have any of the real cartography elements to it. So the users are wanting to get that result out of eCognition and into whether it's Esri or some other GIS platform. Yes, you can export your results. Shapefile is just one of a number of formats that we have there. File geodatabase as well if we're just thinking pure Esri. But again, you have GeoJSON, GeoPackage. These are other formats that are available for export, as well as, of course, raster.
Here's another question. Having images of 10 centimeters spatial resolution and a point cloud with a density of 10 points per square meter, is it possible to do a vectorization at the level of building? I'm not 100% sure.
Assume the way I interpret this is that you're looking to create building footprints, and your goal is to have a vector shapefile with those footprints, so those outlines, so the polygon or polyline or something like that. 10 centimeters is incredible resolution, and if you have the point cloud layer to go along with that, that's excellent. Because if I think of buildings, what's the unique feature of a building? Well, it's elevated. That's at least one of them, and that elevation data will get you further than other means. So there are ways to do that. Probably it's a whole webinar onto itself, but yes, you can use that data to create such vector building footprints.
Okay, I think we have a few more questions. Next one is again about the hexagon concept. So I hope, Dirk, you're listening. How the hexagon, so the question is, how does the hexagon concept works as the raster images are acquired with squared pixel?
Yeah, I would, I mean, we can certainly go back in and view that, but I would suggest for say detailed questions on the whole hexagon concept, go into the community, post your question, and Dirk, again, if you're listening as the creator, you'll spark that discussion, and you can reach out, or actually if you go into that customized algorithm, I believe the contact information for Zetgis is in there as well, and you can reach out to them directly on how this all works, but you'll be able to get those types of details there.
Yeah, and I think it's also important to mention that if you do the hexagon segmentation or any segmentation in eCognition, the outlines of the objects, they're following the pixel outlines, right? So you're not getting an object outline that is crossing a pixel. So the pixel is the basis of objects in eCognition. Good. I think I have two more. Probably gonna
let's take the last two. We've got a few more minutes.
Okay. Yep. How well are deep learning algorithms dealing with DSM, so I guess digital surface models, detecting objects like cars or buildings?
Yeah. So the algorithms will deal with it if you have that as input. Let's put it like that. So if you have a DSM layer, you want to include that in the training of your neural network. By all means, you can certainly select that, and it goes into the consideration for that object. Second part of that was, I believe, how good is it as training, identifying things like cars? I mean, in general, or within eCognition in general, yes, deep learning is being used to classify single objects like cars, vehicles, in all sorts of different types of imagery situations. Not only, say, our top-down imagery that we're used to looking at in remote sensing, but also from mobile mapping data. As the camera moves and finding vehicles. So yes, you can use deep learning to identify vehicles, and yes, if you wanted to do that in eCognition, you can. You as a user will be responsible for either finding that beautiful pre-trained external model or building your own model within eCognition.
Okay, and then I would say that's the last question now for today. It's a tricky one. Might be, which kind of Python packages do I have to install to be able to run the CNN file format conversion?
Yeah, that's one I unfortunately cannot answer. That's beyond my, say, deep learning knowledge. But if you reach out to our support team, we can certainly track that information down for you. If it's not listed, I don't believe we make a specific recommendation in the documentation. But we can certainly ask some of our engineers what their recommendations are and pass that on to you. So go to eCognition.com and open a support case for us on that one.
Yeah, and I also think that we in the next few days we're gonna put up another example in the knowledge base or yeah, in the community on how to deal with external models.
Yeah, as we see more and more people taking advantage of this, we of course will try and get material out there that can, say, walk you through really directly from an eCognition side on that. So great. That being said, got us right to the end. I'm glad we had a lot of time for questions today. It hasn't been the case in the past, so it was really good to get those, field those, see where the different direction the questions are coming from. And so that being said, we'll finish up this webinar. Again, thank you for attending today. If you have more questions that we weren't able to get to today, again, go either to the eCognition community, a great source where you can reach out to everybody, or go to eCognition.com, submit a support case, and ask us directly that way, and we'll get back to you pretty quickly on that. And again, thank you for attending. See you next time, and enjoy version 10.1. I hope you like it as much as we do. Have a great day. Thanks a lot. Bye.